Hello, and welcome to another episode of Learn Extra. Today we'll be going through trigonometry, and we were going through expressions, equations, and graphs. So let's look at a couple. This one says, without the use of a calculator. Let's just get my pen there. Without the use of a calculator, determine the value of the following. Immediately as you see without the use of a calculator, should pop up that you're going to be using special angles, and your special angles are 30, 45, 60, and 90. And another thing that you'd also see is that you've got obtuse angles there and there. So then you should know that you need to use your reduction. Remember, your reduction is your cos diagram. If this is 0, this is 90, this is 180, and this is 270, and there goes back to 360. Here they're all positive. In this quadrant, the second quadrant, only sine is positive. In the third quadrant, only tan is positive. In the fourth quadrant, only cos is positive. So let's then look at the question itself. Cos 100 degrees over sine negative 100 times tan squared 120. Now cos 100, we can use 90 degrees plus 10 degrees. Sine negative 10 stays as it is. Tan squared 120 will be tan squared 180 minus 60. Now, this is a co-ratio. So if you look at 90 plus 10, we know that the co-ratio will give you is negative sine 10 degrees. This is your negative angles. Remember, when sine is negative, the negative comes to the front and becomes negative sine 10 degrees. Now this one, tan is negative in the quadrant 180 minus, which is the second quadrant. So then you'd have negative tan 60 degrees, and we put the square outside the bracket. Now these two are identical, right? So they cancel out, and that just gives you 1. There, that's a special angle. So you'd end up getting negative 3. And if you square that, you get positive 3. And that's your answer. Now that we've done the previous question, let's go on to the next question. It says, without using a calculator, let's get our color, determine the value of the following expressions. Now here we get introduced to two more things. First, your co-ratios. So let's look at your co-ratios. Remember, those are all your 90 plus 90 minus. Sine 90 plus or minus theta is always cos theta. Cos 90 minus theta is sine theta. Then cos 90 plus theta is always negative sine theta. We're also going to be looking at your identities, but in particular your double angle identities. So let's recap on that. Cos 2 theta, remember, is cos theta times, or rather let's say cos squared theta minus sine squared theta. And then your sine 2 theta will be 2 sine theta cos theta. Now let's do the question. So then Looking at this one, remember your negative. Your tan of negative, the negative comes to the front. So it becomes minus tan 60 degrees. This one, cos of a negative angle always remains positive. So this is cos 155 degrees, cos 294 degrees, all over sine 492. We have obtuse angles there, so we need to reduce them. This becomes cos 180 degrees minus 24. This becomes cos 360 minus 66. That becomes sine 360 degrees plus 132. So now, we haven't really done anything there, so it remains the same. This one, cos is negative in this quadrant. So it will become minus cos 24 degrees. This one, cos is positive in this quadrant, so that remains cos 60 degrees. That one there, sine is always positive, because this is actually the first quadrant, and everything is positive in the first quadrant. So that's sine 132 degrees now that's already been done. Now I want to reduce the 66 so that I can actually get a 24 in some way, so at least I'm getting closer and closer to my answer. So there we could use 90 degrees minus 24. And we can also reduce that one to be 180 degrees minus 48. That becomes negative tan 60 degrees minus cos 24. And this becomes sine 24. Remember your corratios. That sine is positive in this quadrant, so it will be sine 48. That becomes negative tan 60. This now, going back to the notes I just did now, is your double angles. So that you could change to sine 2 times 24. But don't forget your negative, because it was there. This could also be that if you wanted. It's the same thing. These two now cancel out. That now gives you a negative times a negative is a positive tan 60 degrees. And that would give you square root 3 over 2. And that's your answer. But remember, guys, when you're done with this question, you can actually go type in the original question into your calculator, and you should get the same answer as your answer. If you don't, then you know you've gone wrong somewhere, so you can backtrack. Let's look at the next question. The next question says, if tan theta is equal to 3 over square root 40, and A is between 0 degrees and 90 degrees, determine the values of the following with the aid of a sketch and without using a calculator. Leave your answers in surd form. This word if, when you see the word if, it actually means use a sketch. So let's first work with what you're given, which is this part here. So tan 3 over square root 40. Remember, tan is y over x. So if you had to then draw a diagram, and this is A, your y is 3, your x is square root 40, and so what are you missing? Your r. So you have to find your r first. Using Pythagoras, remember r squared is equal to x squared plus y squared. Now we substitute all our values. Square root 40 squared plus 3 squared gives you 49. Remember, you have to square root both sides. Don't leave it as r squared. And your r is always positive. So just going back up here, your r is then 7. So now we can actually answer the question. The question said, find cos A. Remember, cos is x over r, which is then square root 40 over 7. And that is your answer. The second question is a continuation of the first question, so we still need our sketch. It says find sine 180 plus a. So this is your reduction formula, so you first have to reduce that. Sine is negative in this quadrant, so that becomes minus sine a. We know that sine is y over r. Let's not forget our negative. Our y was 3 and our r is 7. And that's our answer. Let's look at another part of question 2. It says, given that sine 27 is t, express each of the following in terms of t. And that's very important. So we're given sine 27. And we need to find cos 27. There's no relation in these. So let's first work with sine 27. Remember, guys, sine is y over r. So we actually need to sketch here. And we know that sine 27 is t over 1. So this is your y, and this is your r. So if we were to sketch that, this is 27 degrees. Your y is t, your r is 1. We need to find x. So x squared would equal to r squared minus y squared using Pythagoras. So, which means that x would equal to plus minus the square root of 1 minus t squared. Guys, you can't then separate the square roots. You're not allowed. Remember that you can't cancel across a plus or minus sign. So we look up, and we're only looking for the positive because we're working on the positive side of the x-axis. So x is equal to 1 minus t squared. There. The square root of that. So now we can actually go back to our question. Cos 27. Cos is x over r. Your x, we just found that to be 1 minus t squared, square root of that, over 1, which is the same as just saying the square root of 1 minus t squared. And that's your answer. You've found the answer in terms of t, right? That's it. Let's look at the next one. It says, given again that sine 27 is equal to t, express each of the following in terms of t. Now we have tan 153. The problem is this 153. We need to first reduce it. So let's see. That could actually equal to tan 180 degrees minus 27 degrees. And remember, looking at cost, 180 minus is in this quadrant, which makes tan negative, sorry. So that would be minus tan 27 degrees. Now we can actually work with this because tan is y over x. And if you go back to our previous sketch up here, your y is t, your x is 1 minus t squared, the square root of that. Which means that your answer there is minus t over 1 minus t squared, square root of that. And that there is your answer. You found tan 153 in terms of t. And we actually reduced everything to get it in terms of 27. Let's look at the next question. Given that sine 27 is equal to t, express each of the following in terms of t. Cos 243. Now this 243, we have to reduce it first. So that we can say cos 360 minus, let's just go to our calculator and just check that. So 360 minus 243 is 117. That, remember, cos is positive in this quadrant, so it will be positive cos 117 degrees. Now we need to reduce this again because we still don't have 27. Then we can go cos 90 degrees plus 27. Remember, this is your co-ratios. So 90 plus becomes minus sine 27 degrees. We finally have a 27, so now we can answer our question. If you look at sine 27 was t, so this would equal to minus t. And that's the answer for that one. So remember, don't forget to reduce until you get to what you were given. Let's look at this next question. Given that sine 27 is equal to t, express each of the following in terms of t. Cos 54. Again, 54 is not in terms of 27. So let's see how we can reduce that. 90 minus 54 is 36. Let's check another way. 27 times 2, 54. So there. So this we could write as cos 2 times 27 degrees. Now this is a double angle. So remember, we can reduce this to now 1 minus 2 sine squared 27 degrees. And I specifically chose the sine one because I know what sine 27 is. So sine 27 is t, so this would be t squared. So your answer is then 1 minus 2t squared. Now, let's go to a quick break, and when we come back, we'll continue with question 3. Welcome back. Before we went to the break, we did a couple of basic trig equations and reduction formulas. Let's continue. This question says, determine the general solution of the equation cos 4 theta times cos 40 degrees plus sine 4 theta times sine 40 degrees equal to negative 1. Now guys, general solution, remember that sine theta and cos theta is always k 360 degrees. And that tan theta is always k 180 degrees. Now the reason for this is that, remember, the period of a sine and cos graph is 360 degrees, and the period of a tan graph is 180 degrees. So let's continue with the question. Now if you look at this actually resembles the cos compound identity. So it will be cos 4 theta plus 40 degrees. Actually, it's a negative because remember, the cos, the one with the plus is the one with the negative, equal to negative 1. Now, we want to get rid of this cos so that we only have theta, because we need to really, in essence, just get theta on its own. So in order to get rid of this cos, what do? We second function, remember? Second function cos of negative 1. Remember, guys, we only use second function to find an angle and nothing else. So if you second function cos of negative 1 in your calculator, you'll get plus minus 180 degrees. No, let me just show you. But now we can actually start doing them separately, because then you have 4 theta minus 40 degrees equal to 180 degrees, or 4 theta minus 40 degrees is equal to negative 180. Let's take the 40 over. Now we need to say plus k 360. We'll do this one and finish it and go to the other one. And you also need to also say that k is an element of integers. So that would be 180 plus 40 gives you 220 plus k 360 degrees. Then we divide through all the way by 4. Now theta will equal to 55 degrees plus k 90 degrees. So that's your first general solution. You're not done. So let's do the other part. 4 theta minus 180, I think it was. Let's just go up and see. Minus 40 degrees is equal to negative 180 degrees. That becomes 4 theta equal to negative 180 degrees plus 40 plus k 360. Remember, you can't forget that. This now becomes negative 120 plus k 360 degrees, and you divide through by 4. So that becomes theta is equal to negative 30 degrees plus k 90 degrees. And there, these two answers, including the one that we did up here, are your general solutions. I hope you've had more understanding of what general solution is, but the next question is also a general solution question. So let's try this one. Determine the general solution of the equation 4 sine squared x minus 11 cos x equal to 1. Now the first thing that you should see is that you have different trig ratios. So let's try and get them into the same trig ratios. This is when our identities come in play. Remember the identity sine squared x plus cos squared x equal to 1. So if we manipulate that, we get that sine squared x is equal to 1 minus cos squared x. So we can actually use this there. So then this becomes 4. Remember now, that's 1 minus cos squared x minus 11 cos x equal to 1. Multiplying to this bracket, we get 4 minus 4 cos squared x minus 11 cos x. And let's bring everything to one side. Minus 1 equal to 0. Because essentially it's an equation, and before we can solve an equation, it has to equal to 0. Let's add our like terms. These two are like terms. So then you have negative 4 cos squared x minus 11 cos x plus 3. So can you see, guys, I already actually wrote it in standard form. Now we don't like this negative, so we can actually divide through by negative. And we get 4 cos squared x plus 11 cos x minus 3 equal to 0. Now, factorizing this can be a bit difficult. So what I do is that I always actually put it into normal variables that I can actually factorize. So for example, let me just change colors so you can see that this is different. So imagine this to be 4y squared plus 11y minus 3. And this is this now you can factorize because it's 4y and y plus 3. Right? So take this and now go translate it back into causes. So let's go back to green so you know what we're doing. So back into there it would be 4. Remember our y represents our cos. Cos x minus 1. And then cos x plus 3 equal to 0. Now, like a normal equation, we make each bracket equal to 0. So that's 4 cos x minus 1 equal to 0. or cos x plus 3 equal to 0. Let's solve this one first. 4 cos x is equal to 1. Divide by 4 on both sides. So then cos x is equal to a quarter, or cos x is equal to negative 3. Now, again, we use our calculator. We say x is now second function of cos quarter. And that you should get to be plus minus 75,52 degrees plus K 360. Don't forget that. Now, if you go punch this into your calculator, you're going to get maths error. Let me show you what I mean. So let's do this. Shift cos of negative 3. Can you see? That's an error. So now you get error. Why would you actually get an error? Well, because remember cos, let's just go back to our color again. Cos x only exists between negative 1 and positive 1. So anything smaller than negative 1, which in this case is negative 3, will give you an error. And anything bigger than 1, so it could have been 5, would also give you an error. So there's then no solution. Remember, guys, don't just leave it at that. You have to write no solution, because you writing no solution means that you've actually answered the question. Now, guys, this is the only solution that you can get to this answer. But this solution can actually be expanded. So let's look at how we can do that. Either x is equal to plus 75,52 degrees plus K 360, or I'll just put a big or there. X is equal to negative 75,52 plus K 360. Remember now the negative angle, if you punch it into your calculator, let's just try this quickly. If I punch in minus 75.52 plus 360, you'll get a different answer from if you do the positive. So if I do the positive, and if I say 75.52 plus 360, can you see? That's a different answer from what you got. So essentially what this shows that these are two different answers, but in one solution. And that is your answer. Let's go to a quick ad break, and when we come back, more trig. Before the ad break, we went through a couple of trig equations. Now we'll do trig graphs. Let's have a look. It says the graphs of the functions f at x equal to a tan x and g of x equal to b cos x for x greater than 0 degrees but less than equal to 270 degrees are shown in the diagram below. The point, this point here, 225 degrees and 2, lies on f, and the graphs intersect at points P and Q. Let's look at the graphs. So you can see your points of intersection there and there. The first question says, determine the numerical value of A and B. Now, we were given a point, this point here. Remember the rule that says any point on the graph will satisfy the equation of the graph. So we'll actually use this point and place it into the equations of f and g to get our values. So f at x was a, just looking at it quickly, tan x, and our point that we're given here is 225 degrees and 2. This is your x, this is your y. And remember, f at x is the same as saying y, so this actually represents y. So 2 is equal to a tan 225 degrees. Then we'll divide both sides by tan 225 to get the value for a. And if you want to do that on your calculator, you just say 2 divided by tan 225 is 2. That means that A is equal to 2. Now that we've done finding the value of A, let's find the value of B. So if you look at this point here, it doesn't lie on the cos graph. I mean on the cos graph, it lies only on the tan graph. So we can choose this point here. So g of x is equal to b cos x, and we've chosen now 0, 4. So that's your x and that's your y. So that means that 4 is equal to b cos 0. And if you find cos 0 in your calculator, you'll find that that's 1. That means that b is equal to 4. So we're done with this part of the question. Let's look at the next one. 5.2 says, determine the minimum value of g of x plus 2. Now let's just look at g of x. It's this one. I'm just going to highlight it for you there, so we're clearer. There we go. So that's g. So going back to it, remember g previously was 4 cos x, which means then this would be 4 cos x plus 2. So looking at g, the minimum value, guys, is the lowest number or lowest value that this graph has. And if you look at that, it's there. It's negative 4, which means that this would be negative 4 plus 2, which would equal to negative 2. So that means then your minimum value is negative 2. That's the lowest point that it can be. Let's look at the next question. 5.3 now says, determine the period of f at a half x. Now guys, a couple of notes I need to give you is that for your period, for sine x and cos x, and really rather let me just say sine k of x and cos k of x, then your period is equal to 360 degrees divided by k, and for tan k of x, your period is 180 degrees over k. So now going back up, it says the period of f. F, remember, was our tan graph. There. So that means then our period would equal to 180. And what's our k? This is our k. K is like the coefficient of x. And if you go do that, you'll find that that's 360 degrees. And that's that question. Let's go on to the next question. 5.4 says, show that if the x-coordinate of P is theta, then the x-coordinate of Q is 180 minus theta. Now if we go up here, P and Q are your points of intersection. Now we need to find what the x of this is. In other words, what this point is up here. So remember that the equation for P was 4 cos theta, right? No, F was 4 tan theta. Now if we go replace this x-coordinate, which is theta, with this one, we get 4 tan 180 degrees minus theta. Using our reduction formula again, this becomes minus 4 tan theta, because tan is negative in that quadrant. Then we do the same for the other one for G, which was 2 cos theta. So we substitute theta with 180 degrees minus theta. Cos is also negative in that quadrant, so that becomes minus 2 cos theta. Now, because we know in order to find a point of intersection, we need to make the graphs equal. So that's what we're going to do. We'll make, let me just change color so you guys see what I'm doing. We'll make this equation equal to that equation. So we have then minus 4 tan theta equal to minus 2 cos theta. If you then take the negatives on both sides, it will be 4 tan theta equal to 2 cos theta. But really, essentially, isn't that how we found P? Because we found P by making the graphs equal, right? Therefore, Q x coordinate is 180 minus theta. And really, guys, you can double check your answers there and there by looking at the graph. Can you see at this point, your y's are negative, your functions are negative. So that means this should be a negative and that there should be a negative, which then shows you that this is an x coordinate. Now that we've done that previous question, let's go into another type of question. But before that, let's look at this. These are the things that you need to know about the trig graphs. Do you know the shape of the graph? In other words, do you know the shapes of the different types of graphs? Sine, cos, and tan, they all look different. The domain. The domain is the x values for which the graph exists. Your range is the y values for which the graph exists. Your turning points. Remember your turning points, you have the one at the top, so that's your maximum, and the one at the bottom, that's your minimum. Now that's only for your cos and sine. Your amplitude. I'll give you a basic. Your amplitude can be determined by this number in front. So it's a coefficient in front of the trig function. Your period. So this is the coefficient of the x. See, there's a difference between the amplitude and the period. Amplitude, the coefficient in front of the trig function. Period, the coefficient in front of the x, or the y, or b, but it's the coefficient in front of this part here. Frequency. Frequency is how often a full period occurs. Let's now look at the next question. Question 6 says, given f at x equal to 1 plus sine x and g of x equal to cos 2x, sketch the graphs of f and g for x an element of 90 degrees and 360 degrees included on the same set of axes. Now just to get to these brackets here, remember guys, square brackets means that it's included, so it's a closed dot. Round brackets means that it's excluded, so it's an open dot. Now this here is actually what we call a vertical shift. In other words, we're taking the function and we're shifting it either up or down. If it's positive, like in this case, it's shifted up. If it's negative, it's shifted down. And this number in front tells you the number of units that you're moving it. So let's go into this question. We can actually punch all of this into our calculator. F at x equal to 1 plus sine x. And we want to start at 90 because that's what they gave us, and end at 360. And you want to go up in 90s, like we always do for sine and cos. And there. So at 90 degrees, it's 2 90 degrees is 2. Let's get our pen again. At 180 is 0. No, sorry, at 180 is 1. 270 is 0. And 360 is there. So if you join those, I prefer doing it this way. There's your graph. So you can actually see it from there. Let's just erase this bit so it's out, it looks more like it's above there. You can see it from there that we've taken the sine function and we've shifted it 1 unit up. Let's look at the other one. G of x equal to cos 2x. Now this 2 here, remember when we did the cos and sine graph, usually we go up in 90. So if I were to punch this into our calculator, cos 2x, start at 90, end at 360. Now we need to go up in 45s because that's, how do I get 45? 90 degrees, which is what we usually go up in, divided by 2 gives you 45 degrees. So looking back now at our calculator, go up in 45s. Okay. Start at 90, end at 360, go up in 45s, and there. So at negative 1, x is 9. At 90, sorry, it's negative 1. So let's do this. 90, negative 1. Then there, at 135 is 0. 180 is 1. There is 0. 270, negative 1. And there, 0, and then there. So let's just draw it. So now we're going to draw it. This is a turning point, so there, and then it goes up, and then approaches another turning point there. So now there's a graph of cos 2x. As you can see it, the frequency has decreased. Now let's go on to the next question. It says, for which values of x will f at x be less or equal to g of x for x an element between 90 and 360? Now this, guys, I always read it as below. In other words, where is f going to be below g? So if you go up, where's the green, which is f, going to be below the pink? And I just want to change color so you can see it. The green is below pink there to there, and there to there. You know this point and that point, but you don't know there, that point there, and that point there. So we have to find that point. How do we find those points? Point of intersection. And how do we do that? We make the graphs equal. So our two graphs are 1 plus sine x, and we make it equal to cos 2x. Now remember, when we did equations, is that you need to then get everything in terms of one trig function. And we can change cos 2x because it's a double angle. So we could use 1 minus 2 sine squared x. Remember this is an equation, so we have to bring everything over to one side and make it equal to 0. So 2 sine squared x plus sine x equal to 0. Remember, the ones will cancel out. We can take out a common factor there of just sine x. Then we have 2 sine x plus 1 equal to 0. So then sine x would equal to 0, or sine x would equal to negative a half. Now let's find the solutions. If you look at sine is positive. If you look at cos, there and there. So then x would equal to, in that quadrant, just as it is, so second function sine of 0, which is 0 degrees. And in that quadrant, x would equal to second function sine, remember that quadrant is 180 minus second function of sine 0, and you'd get 180. So I'm just going to underline those solutions. Let's come back to this one. There again, if you draw a little cast again, it's there and there. So would be, no. It's actually not here, guys. It's positive. It's negative. Remember this negative here? There and there. So x is equal to 180 plus the second function sign of a half. And that you'd get to be 210. And in that quadrant, we'd say x is equal to 360 of a half, and x there would be, no, it would be 330. There. So if you look at this, did you notice how I didn't put the negative in there? We don't put the negative in there, and we get our two solutions there and there. Now let's go up to a graph and compare the solutions. 0 and 180. Look, there's 180. That one there would be 210. 0 isn't in the restriction, and that's why we don't actually consider it. And that one there would be 330, which is there, and there, which is 360. So then our solution would be x is an element between 180 and 210. And because there's 2, x an element between 330 and 360 degrees. And that there is your answer, which is there and there and there and there. So that's it for today on trig. We'll see you next time with more trig applications. See you then. Bye.